Hello, and today we're going to take a look at simplifying radicals, specifically square roots. Now, square roots have a lot of different problems, but we're going to focus on ones with numbers underneath, specifically integers. And so we're going to be taking a look at these today so you can simplify square roots. Now, the key to understanding this is the simplicity of perfect squares. So what I mean by that is the square root of 16 is equal to 4. We know that because 4 times 4 equals 16. And another thing you've probably learned is the square root of 25 equals 5. Well, if we keep going, we can find other perfect squares like square root 400 equals 20. But we can learn something new. Let's take the square root of 16 and multiply it by the square root of 25. Well, 16 times 25 is 400. And this is a very important fact, 4 times 5 equals 20. What this means is, of course, that we can go backwards. We can take a big square root and we can split it into two smaller numbers. This is called the product rule. What it means is you can take a radical, you can break it into two parts or more, then multiply to the original. So if we look at this, we have square root 60. We can make that 20 times 3, but remember, it's not 20 times 3, it's root 20 times root 3. Or root 15 times root 4, or root 10 times root 6. Let's take another example, 150. What's a way to multiply 250? 15 times 10, or 25 times 6, or 75 times 2. All these multiply back to the original number. But the product rule has some more useful answers than others. If we look at square root 60, square root 15 times square root 4 is more useful than the others. Well, why is that? Let's look at our next fact. Radical breaking. So we're going to use the product rule to break a radical into perfect and non-perfect parts. Don't let that confuse you. We're just going to take, for example, square root 24. And we're going to pick two numbers that multiply 24, but we're going to specifically pick square root 4 times square root 6. Now, why did we pick square root 4? Because square root 4 is a perfect square. Remember, there's a number that multiplied by itself equals 4, and that, of course, is 2. So we can take square root 4 and square root 6, and that equals square root 24. But now we can turn that square root 4 into a 2. And so square root 24 is more simply 2 square root 6. The same thing works with square root 75. 25 times 3 is 75. So we split root 75 into root 25 and root 3. But now root 5, root 25, and root 3 are multiply back to 75, but 5 times root 3 is equal to root 75. You can type them into a calculator that gives you decimals. Type root 75, then type 5 times root 3. They're the same number. That's because we're using the product rule to find the perfect squares. Let's take root 48. Root 48 is the same as 16 times 3. And why did we choose 16? I mean, we could have done 24 times 2, right? Because 16 is a perfect square. 16 square root is 4. So you can see the pattern we're using here. We're doing square root 72. So we're saying, hey, 72 is 36 times 2. The square root of 36 is 6. 6 root 2. So now some of these roots are sneakier than others. So what we're going to do is break it down all the way. If you get lost, let's take square root 242. That might be difficult. So first, we'll just split it to 22 times 11, because that's what we can think of right now. Maybe you use the calculator, Maybe you figured out that it divides by 22 because of all the 2 base numbers, but whatever it was, you're like 22 times 11 is in fact 242. Now, what we're going to do is keep breaking it down. We're going to take that 22 and we're going to split it into 2 times 11. So think about this with me. 2 times 11 is 22, and 22 times the first 11 on line 2 equals 242. What this means is we have 2 square root 11s. And of course, those two match. If you multiplied them together, you get a perfect square because the square root of 121 is the same as 11. So this is a sneaky way to beat a sneaky root if you can't figure one out. Now let's take one we've solved before, square root 60. Now we know that square root 4 times square root 15 was the answer. But let's say you couldn't find 4. Let's say your brain's stuck and you do 10 and 6. Well, we can keep splitting it down. We can say 10 is 2 times 5, and 6 is 3 times 2, and then we can take those 2's and multiply them together. Because root 2 times root 2 equals regular 2. Remember, root 2 times root 2 is just, you guessed it, root 4. And so the square root of 4, of course, you've known this since you were a little kid, is 2. And square root 15 is the square root 3 times the square root 5. So we took the numbers and we broke them down into their absolute most basic parts as primes, and then we were able to put them back together by multiplying and get the answer. Now, additional practice. Let's see if you can simplify these roots. Square root 120. I'm going to give you time in between each, and then we'll tell you the answer. Square root 4 times square root 30, because 4 times 30 is 120, and the square root of 4, of course, is 2. 2 root 30. Let's try square root 200. Square root 200 is the same as 100 times 2 as roots. Root 100, root 2. And then let's change root 100 to root 10. 10 root 2. Square root 108. That's square root 36 times square root 3. And square root 36 is 6 root 3. Now, as you're thinking about these, I want you to consider what we're doing. We're finding the perfect root. And again, if you get stuck, break it down all the way to prime numbers, and you can find the answer. Here we have square root 128. That's the same as square root 64 times square root 2. And square root 64 is 8 root 2. Before we quit, let's look at 2 common mistakes I see students do. First, remember, not all roots can be simplified with perfect roots. Some are already simplified. Sometimes the answer is just what you started with. So square root 26. That's the same as root 2 times root 13, but neither one of those is a perfect root. There's no way to simplify it. The simplification of square root 26 is square root 26 because there's no perfect root that multiplies to it. And root 2 times root 13 is the prime numbers. There's nothing else we can do. Let's look at square root 70. That gives you square root 7 times square root 10, but neither one of those is perfect root. Let's try 2 times 35. Maybe that'll work. But again, no, neither one of those is a perfect root. There isn't one. So the answer to square root 70 is square root 70. Now, the other main mistake I see, besides trying to look at it infinitely and finally giving up, the other mistake is remember when you were turning a perfect square into its actual root, not to leave it the same. Here's what I mean. Let's say you did square root 125, and that's 25 times 5. We did this one earlier. But then you just erase the root without changing root 25 to 5. Remember, it's 5 root 5. Square root of 25 is 5. It's not 25 itself. Make sure you reduce the perfect square. You learned these a long time ago when you learned multiplication tables. Square root 20, what number times itself is 4? Because 4 is our perfect root, right? It's 2. So 4 root 5 is not the answer. It doesn't equal root 20. 2 root 5 is. Now, I want to thank you for tuning in to our video on direct math. Hope to catch you again soon in the next one.